Okay, so I just want to talk to you about interpreting some of these curves on the graphs that we're looking at and what that means. So, as you can see, there's four different ways that a graph can curve. It can be curving up and to the right like this. It can be curving to the right and down like this. It could be curving down and to the right, and it could be curving up and to the right like that. So there's four different ways to look at this. Let's consider it a position versus time graph right now. On a position versus time graph, what tells you the velocity? Well, it's the slope of the line. Well, you guys aren't familiar with how to calculate the slope of a curve yet. This is a curve, so it's not a line. So let's look at the instantaneous slopes at each point. We call that the tangent line, the instantaneous slope at any point. So let's look at what happens as we go up this direction here. This black line is my slope, and as I move along this curve, we start with a pretty steep slope for this line. But as you go, the steepness of that line gets shallower and shallower and shallower, and then eventually to a slope of 0, where it's straight across. So what happened in that curve? I'm going very fast in terms of velocity, and then as that slope gets smaller, that means the velocity is getting smaller. So this curve here, a curve like this, is slowing down. I'm slowing down until I get to 0, and then I turn around. Now my slope is negative. So if I have a negative velocity, that means I'm going in the other direction. So I've slowed down, stopped, and now I'm going to speed back up. But speed back up negative. You can see I start with a shallow, short slope there in the negative direction. And as I go, it gets steeper and steeper and steeper. So that means I'm speeding up. My velocity is now getting larger, but in the negative direction. So what happens in the other direction? On this curve, you can see that the slope starts to get shallower again until I get to 0. So from here, I slowed down again and then got to 0, and then I turned around to go back to the positive direction and speed back up. So whenever you're looking at these curves, consider following it with your hand like that and see what's really going on with your slope as you go through these, because the slope is really what's determining how we read this, right? So we can read these velocities based on the slope. So I'm fast, I'm slowing down, I stopped, I turned around to speed back up. Now I'm slowing down again, I stopped, I turned around and sped back up. Let's consider that real quick for acceleration in terms of velocity. So if instead of position, that was velocity over here. So we know now the tangent line is the acceleration. I have a very high acceleration here. I'm getting faster very fast. And then how fast I'm speeding up is slowing down now. Right here, I haven't stopped. Remember, this is a constant velocity here. So even though the line here, that means my acceleration is 0. So what has happened was I'm actually going at a constant speed right there. And then what happens when your acceleration turns and becomes negative? That means we're slowing down. We're going to slow back down now that we have a negative acceleration. And we don't stop. We haven't turned around yet because this is a velocity graph. So we don't stop until the velocity gets to 0. And now when the velocity goes into the negative, that's when we turn around. So the negatives is where it gets pretty confusing, because now we still have a negative acceleration, but we're actually speeding up in the negative direction. So this negative acceleration is actually, the velocity is speeding up in the negative direction. So we're getting faster and faster in the negative direction until we get here when acceleration is 0. That means we have a constant velocity in the negative direction. And then look at this. This is strange. I've got a positive acceleration, but as you can see from the graph here, the velocity is getting smaller. It's getting closer to 0. So we're actually slowing down. We're approaching 0 miles an hour because even though our acceleration is positive, it's because we're slowing down in the positive direction when we were going in the negative direction. So because we're becoming more positive, that allows my acceleration to be positive. And then we get to 0. That's when we're not moving, that's when we're not moving, but we still have that acceleration in the positive direction. And that's why we continue to move past that. So we've turned around right here, and we're continuing to accelerate in the positive direction. Acceleration graphs like this can be confusing, so it's just going to take a lot of thought on your end to really sit there and think about what this means as a position versus time graph or as an acceleration versus time graph.